In this video, we're going to be talking about sketching angles in standard form and finding coterminal and reference angles. And today we'll be working just with radian angle measures. So to start out, I just want us to look at an XY plane and just label some important angles in radians. This is kind of going to be a starting point. It's going to allow us to think about where the rest of the angles in radians belong. So remember that whenever we are starting to sketch an angle in standard position, we're always going to start on this positive x-axis. So that's going to be our 0 radian mark. Okay, we also know that to go all the way around the circle, it's 2 pi. So over here we're going to have 0 radians as well as 2 pi radians if you were to go all the way around. Okay. So if all the way around is 2 pi, then halfway around, all the way over to this other x-axis, that's going to be just pi. And then if you think about this line straight up and down, right between 0 and pi, that's going to be pi over 2, or pi halves. And then right between 1 pi and 2 pi is 1.5 pi, or 3 pi over 2. And you're definitely going to want to have these kind of 5 angle measures not necessarily memorized, but know where they belong. So it's going to help you figure out where a lot of the other radian measures go as we start sketching in standard position. So remember, as we're sketching in standard form, there's kind of 3 things you need to remember. First, you're always going to start on the positive x-axis. So your initial side is always that positive or right side of the x-axis. You're going to move counterclockwise if the angle is positive, and then you're going to move clockwise if the angle is negative. So if you look at this example here on the right, let me go ahead and zoom in a little bit on it. We are trying to sketch the angle negative 7 pi over 4. So we start here at our, let me get a green pen, start here at our initial side, and then that red line indicates that we're moving clockwise, right, because our angle is negative up here. And then we need to go 7 pi fourths around the circle. So sometimes it's hard to think about in radians, where does 7 pi fourths fall, or what would that be? So it might be helpful to think about, okay, the full circle would be 2 pi. So let's figure out how many pi fourths 2 pi is. So what we're going to be doing a lot of today is we're going to be comparing fractions, because radians are given in fractions. One thing you have to remember is if you want to rewrite a fraction with a different denominator, you just need to multiply the top and bottom by the same number. So if I multiply the top and the bottom of this fraction by 4, then I'm going to get 8 pi over 4. So 8 pi over 4 would be all the way around the circle. But I'm only going 7 pi over 4, which means that I need to basically go almost all the way around, but stop about pi fourths of the way before getting back to the starting point. And you'll see that in the picture on the right? This red angle starts and it goes almost all the way around, and then it stops, and there's about pi fourths of the circle left. Okay, let's go ahead and work through some more examples sketching these in standard form. So again, we're going to want to go back to what we've used up here, that we know that the right side is 0 radians, straight up is pi halves, to the left is pi, and then down is 3 pi over 2. So definitely keep that in mind as we work on these. So we have pi thirds in this first example. So if you think about it, we know that if I'm going to start here with my initial side, if I were to go all the way around to the other side, I would get all the way to pi. So what I basically need to think about doing is going only a third of that distance. So I'm going to think about like dividing this whole chunk into thirds, right? And then that means that each of these lines represents going pi thirds of the way around. And if I just want to go pi thirds, then I'm just going to go to this first line right here. And that is going to be my pi thirds angle. I'm actually going to erase these other ones just so that they don't confuse us. But thinking about dividing that chunk into bigger chunks, into smaller chunks, can be really helpful. All right, let's do a negative angle. So number 2, I have negative 5 pi over 2. So this is negative 5 pi halves. So since it's negative, we know we're going to be going clockwise. And as always, we're going to start with this initial side. So here, let's think. We know that if I were to go the equivalent of 90 degrees, right, just to the next horizontal or the next axis, it would be pi halves. So I basically need to go 5 pi halves. So I went 1 pi halves, 2 pi halves, 3 pi halves, 4 pi halves, 5 pi halves. So 5 pi halves is going to be that angle right there, where I go all the way around the circle one time and then go down an extra pi halves. All right, in number 3, I'm sketching 3 pi over 4. Okay, so let's remember that straight up and down is going to be pi halves, and then to the right is pi. Of course, over here is 0. So I'm looking for 3 pi fourths. One thing that might be helpful here, just a kind of another strategy or way of thinking about it, is kind of take away the pi's and just think about these fractions as I've got a 1/2 on top, I've got a 1 here, and I've got a graph. I've got to go 3/4 of the way. And 3/4 is right in between 1/2 and 1, which means my 3 pi fourths angle is going to be right in between the pi halves and the pi mark. Okay. I'm going to erase these just so that as we move forward we don't get confused about why we wrote random numbers there. So then my angle of 3 pi fourths is going to be that angle right there. All right, let's do negative pi over 6. So negative pi over 6, if we think about starting here at the initial side, let's pretend we were just going to go negative pi. If we were going to go negative pi, I would go all the way to this opposite side of the graph. What I need to do now is think about dividing that into sixths. So if I'm, instead of going the whole distance pi, I need to go a sixth of that distance. So you can kind of think about just like chopping this section into 6 bits. And then each of those lines would represent going pi sixths of the way around the graph. And if I only want to go 1 pi sixth, then I'm just going to go from my initial side down to that terminal side right there. And that would be negative pi over 6. So if it helps you to kind of look at the whole and then chop that into 6 pieces, that might be a good way of thinking about that, that angle. Okay, what I want you guys to do is I want you guys to go ahead and take a look at 5 and 6. Try them on your own. Go ahead and hit pause on this video and then hop back on when you finish sketching them to double check your work. Okay, so these 2 angles in standard position should look like these pictures that I've drawn. Number 5 should have been easy. That's one of the main angles that we're going to have memorized, the pi halves angle. Number 6 may have been a little trickier for you. So remember that since it's negative, you're going to be going clockwise. And one thing that I thought about when I was doing this is that 11 pi over 6 might be kind of hard for me to visualize. But I know that 2 pi is the full circle. So I'm going to change that 2 pi into sixths, just so I know how many sixths is a full circle. And that tells me that 12 pi over 6 is going to be the full circle around. So if I'm just going 11 pi over 6, it means I'm going to be going almost all the way around the circle, but I'm just missing 1 pi sixth. So that's why I kind of stopped just right before. All right, so hopefully we're feeling comfortable sketching angles in standard position, because now we're going to start looking at reference angles. So remember, a reference angle, these are the same as what we talked about in degrees, it's just now we're doing them in radians. So remember, the reference angle is formed by the terminal side of the angle and the x-axis. So it means that the angle is always between 0 and pi halves. In degrees, it's always between 0 and 90 degrees. And don't forget that it's always positive. So we're going to go ahead and do some practice with some angles that are already sketched in standard position, some that we're going to sketch, and especially practice finding the reference angle. So let's take a look at number 1. We're looking at the angle negative 7 pi over 6. So before we even start talking about what the reference angle is going to be, let's just go ahead and draw what it should be. So remember, it's always going to be the terminal side and the x-axis. So we are looking for this angle right there. So there's several different ways of thinking about these reference angles. In this case, the angle, like think about this red angle is negative 7 pi over 6. think about that as telling you how far you have to go around the circle. So you had to go 7 pi over 6 around the circle. Now we need to figure out, okay, at some point you got to the x-axis and then you went a little bit further up. So how much further up did you go after you hit the x-axis? So what we can think about is if we have 7 pi over 6, we know that to get all the way to the x-axis, that was a full pi. That was just pi distance around the circle, right? So if I can just subtract that pi from 7 pi over 6, then it's going to allow me to know how much further I had to go to get to negative 7 pi over 6. So let's go ahead and do a quick review on how we subtract fractions. So I'm going to go ahead and write this pi over 1. And when we're subtracting fractions, they need to have the same denominator. So I am going to multiply the top and the bottom here by 6. And remember, as long as I multiply the top and the bottom of a fraction by the same number, then it's going to be equivalent. So I've got 7 pi over 6 minus 6 pi over 6. And when you have the same denominators, you would just subtract the numerators. So 7 pi minus 6 pi would just be 1 pi over 6. So pi over 6 is that reference angle. It's how much further I had to go past pi to get to the terminal side. Okay. Let's go ahead and take a look at number 2 and see if we can use the same sort of reasoning. So let's first just go ahead and kind of trace what angle we're looking for. So I'm looking for the angle between the terminal side and the x-axis. So that red angle. So in the previous example, we were looking at, okay, we got to the x-axis, how much further did we have to go? In number 2, it's a little bit different, because if you look at this red angle, the negative 3 pi over 4, we never actually make it to the x-axis. The question we're asking here now is, okay, I went negative 3 pi over 4 and then I stopped. How much further would I have had to go to get to that x-axis? Okay, so we're kind of going to use the same reasoning, but here we're going to say, okay, I know that to get to the x-axis I would have had to go pi radians, but I only went 3 pi over 4. So how much was I missing before getting to pi? So I'm going to do pi minus 3 pi over 4. And again, if I want to subtract these fractions, I need to have the same denominator. So I'll go ahead and multiply the first fraction by 4 over 4. So I have 4 pi over 4 minus 3 pi over 4, which just turns into pi over 4. And that's that little reference angle right there. All right, let's take a look at the next couple. I'm actually going to press pause and let you guys try these ones on your own, and then come back and go ahead and take a look at my work. All right, hopefully you were able to find the correct reference angles for number 3 and number 4. One thing that you'll recognize and you'll notice with finding a reference angle is that I couldn't give you a formula that says you always do pi minus the angle, or you always do 2 pi plus the angle, or the angle minus 2 pi. You have to really look at your picture and look at where your angle is and think about what angle you're trying to find. So like in number 3, I was looking at the angle 5 pi thirds, and I knew that 5 pi thirds is going to end up down here in the 4th quadrant. And so this reference angle that I'm looking for is kind of asking myself the question of how much further around the circle did I need to go to complete the circle, right? So that's why I did 2 pi minus the 5 pi over 3. So you really just got to look at what your angle is that you're trying to find, look at what angles you know, and then think about how you can get an accurate reference angle. Okay, let's talk about finding some coterminal angles. So just a reminder that coterminal angles have the same initial and the same terminal side, which means that they start and stop in the same spot. So oftentimes what we want to do is we want to find a coterminal angle that's between 0 and 2 pi, okay? Which means that the coterminal angle would be positive and less than 2 pi. So the reason why we care about that is because if we do anything smaller than an angle of 0, then we're going to have a negative angle, which isn't incorrect, it's just not necessarily preferable. And anything bigger than 2 pi would mean that we had at least one extra loop in there. So we basically are going to try to find coterminal angles that are positive and that don't have any extra loops in them. So we are going to practice finding coterminal angles between 0 and 2 pi. And our method here is going to be very similar to our method when we were finding coterminal angles in degrees. And when we were finding coterminal angles in degrees, we would add or subtract 360 degrees. Here we're going to add or subtract 2 pi radians. So again, this is going to be a lot of practice in remembering how to add and subtract fractions. So let's take a look at number 1. So 14 pi over 4. So again, my goal is to find a coterminal angle that's between 0 and 2 pi. So what I'm going to do first is I am going to figure out what 2 pi, how many fourths 2 pi is. So I'm just going to go ahead and multiply 2 pi over 1 times 4 over 4. So I know that 2 pi is 8 pi over 4. So I'm trying to find an angle that's bigger than 0, so it's positive, but it's less than 8 pi over 4. And the way I'm going to do that is I am just going to start adding or subtracting 2 pi. Now here I'm going to subtract because 14 pi over 4 is bigger than 8 pi over 4. So I'm going to go ahead and subtract 2 pi. And wait, we just decided that 2 pi is the same as 8 pi over 4. So let's just go ahead and subtract 8 pi over 4. Then we have 14 pi minus 8 pi, so that turns into 6 pi. So you're just subtracting the numbers in front. And then my denominator stays the same. Now, if we look at 6 pi over 4, that's still positive, so it's bigger than 0. And it's also smaller than 8 pi over 4, which means that 6 pi over 4 is a coterminal angle that's between 0 and 2 pi. So let's do the same thing with number 2. The first thing I'm going to do is figure out what is 2 pi in sixths. Okay, I'm dealing with sixes in the denominator here. So let's just kind of figure out what is 2 pi. And 2 pi is the same as 12 pi over 6, which means that I'm looking for an angle that's less than 12 pi over 6 and bigger than 0. It also means that when I start adding and subtracting 2 pi, what I'm going to want to add and subtract is this 12 pi over 6. So 13 pi over 6. Well, that's too big, right? 13 is bigger than 12, so it's bigger than 2 pi over 6, 12 pi over 6. So I'm going to subtract that, and I'll just be left with pi over 6. Now pi over 6 is a positive angle, and it's smaller than 12 pi over 6, which means that that's the coterminal angle I'm looking for. All right, let's find a coterminal angle of a negative angle, like we had here in number 3. So I'm dealing with fourths, so let's go ahead and figure out what 2 pi is in fourths. So I have 8 pi over 4. So looking at this negative 9 pi over 4, that is a negative number. It's too small. So I am going to add 8 pi over fourths to it. So I'm adding 2 pi here because I want a bigger angle. And when I do that, I get negative 1 pi over 4. Now, negative 1 pi over 4 is still a negative angle. And remember, I'm trying to get a positive coterminal angle. So I'm going to add 2 pi again. I can add or subtract 2 pi as many times as I want. So if I have a negative 1 pi plus an 8 pi, that means I'm going to have a positive 7 pi over 4. Now here I've got a positive angle, and 7 pi over 4 is less than the 8 pi over 4, so it's less than 2 pi. So that is going to be my coterminal angle. All right, I am going to fill in the next 3. Go ahead and hit pause and then come back on and check your answers. So here are your filled in angle measures of the coterminal angles for 4 through 6. And remember, these are coterminal angles, so they start and stop at the same point as my original angle, but they're between 0 and 2 pi. So they're positive and they are less than 2 pi, which is one full circle.